Hello guys, and welcome to the tutorial. Okay, so in this video we're just going to show that x squared plus y squared plus z squared is greater than or equal to the product of xy plus the product of yz and the product of zx, for which all these variables x, y, z are real values. Okay, so to solve this problem or to show this inequality, we need to engineer some inequalities which will help us to arrive to this expression. Okay, so there are multiple ways which we can do that. Okay, but in the first case, we are just going to consider the expressions on the on the right hand side, as well as yeah, we'll consider everything actually. But here we want to come up with inequalities which are true, because we want to, after deriving those inequalities, they will help us to arrive to this stage. So here we observe that we have xy, you have yz, you have zx. All right. So if I put here we have x squared and the y squared is z squared. Okay. So let's say if we start with this part, which is xy. Okay. So let's concentrate on xy first. So xy, and if we put the inequality as well. Okay. X, since we have variable, we are dealing with variables x and y. Yeah, so focus on the fact that we are dealing with variables x and y. So which means we can say y squared plus, x squared plus y squared is actually greater than or equal to xy. This inequality may hold true, but of course we haven't verified it yet. But if you want to verify it, you can try to put some values to see if it holds true. Okay. But in this case, I'm just gonna put a 2 here. I'll explain later why I'm putting a 2. All right. Yeah, the reason why I'm putting also a 2 is because let's say if x is 1 and y is 1, right? If I substitute the values, let's say x is 1 and y is 1. If I substitute 1, 1, I will end up with a 2 here, because it's greater than or equal to. If you substitute a 1, 1, we end up with a 2 as well, which still holds true. So yeah, that's why we have to put a 2. So we have this first inequality. So because this inequality is actually our guideline, it helps us to engineer inequalities which will help us to show to arrive to this stage. Okay, so we observed that we have an xy in this expression, and we also have an x squared, a y squared, which we will have on this left side of the equation. Okay, so let's consider the next part, which is yz. Okay, so yz, we are just going to put a yz here, which means you are concentrating with the y and z variables only. Okay, so since we have yz, let's just put y squared plus z squared. All right, so we are going to also put a 2. So from the previous example, we observed that if we substitute 1 and 1, that's the reason why we also have to put 2, so that the inequality can hold true where we have an equal sign. Why are we putting an equal sign? Because the final expression is an equal sign. I hope you observe that part. Okay, so then we have the last part, which is zx. Okay, so we're gonna put a zx here, greater than. So we're gonna put a 2 as well. So since we have variables z and x, let's just put z squared plus x squared. Okay, so we have the possible combinations of summations of the squares of the variables x, y, and z. All the possible which you can get, and also all the possible combinations of the products of y and z and x. All right, so what's the next stage now? Of course, these are not the only inequality which you can use. We will try another set of inequalities, but for now, let's focus on this one. So now our objective is to move from this inequality to this expression. Okay, so the way we are going to do it is we are going to add every term on the left hand side together and get an expression, and the same applies for the terms on the right hand side of the equation. Okay, so it's simple addition, just simply to add x squared plus y squared, then you add y squared plus z squared, then you add z squared plus x squared. Okay, then you put the greater than equal sign, then you say 2xy plus 2yz, then plus 2zx. Okay. So now it's time to simplify. So we observe we have an x squared here and an x squared on this part. So these are just like terms, just copying like terms. So we just have to add their coefficients. We have a 2. The same applies with the variable y and the variable z as well. Okay. Okay, so on the right hand side, there are no like terms. Okay, so for now we observe we have tools, which means we can factor out the tools, and if you factor out the tools, we'll be left with x squared plus y squared plus z squared. And now it's more this inequality is now becoming more visible. I hope you can see it now. Okay. Yeah. Then we divide everything by 2 because 2 is the common term, right? And finally, we've managed to show that uh, the square of the variable x, y, z is greater than the products of the variables x, y, and z. Okay, so we have finally managed to show. So that's the solution. That's how we calculate it. Okay, so if you're interested in another method which we could use, it's okay, let me just pause this video and I will record another one on how you can use another approach which is not this part. Okay, so thank you for watching, and see you next time.